Now let's discuss Prim's algorithm. It's a greedy algorithm that finds a minimum spanning tree for a weighted undirected graph. It selects the root vertex in the beginning and then traverses from vertex to vertex adjacently. Now let's see the code. At first we import heap q to extract the smallest edge weight, and then we define a function called Prim's algorithm with the attributes graph and start. The graph represents the dictionary which stores the key value pairs, where key is the current node and value is the dictionary of the neighbor nodes, and start is the start node. Now we initialize MST with an empty list, visited with set, and heap with 0 weight, start node, and none. None represents there is no parent node initially, and total cost with 0. Now we use while loop. Here we use the heap pop of heap to extract the edge with the smallest weight. Now here u is the current node. If u is present in the visited set, then we use continue to skip if the node is already in the visited set, or else we add the node in the visited set, and if there is a parent, then we add the parent node and the current node and their weight. Now the total cost is incremented. Now we use a for loop. Here v is the neighbor node, w is the cost. Which at first we check whether the neighbor node is visited or not. If the neighbor node is not in the visited set, then we push the weight, neighbor node, and the current node. And now we return MST and the total cost. Now we define a function called build graph, and here we use graph. We assign dictionary to a graph. Now we take the number of edges as the input. Here u, v, w. U is the current node, v is the neighbor node, and w is the weight. We take the inputs. Here we use the split function to separate, to give spacing between the vertex names. Here we convert the weight into an integer. If we check whether the current node is in the graph or not, we check whether the current node and neighbor node is in the graph or not. If the current node is not present in the graph, then we initialize the node if not already present, and we add edge from u to v and v to u since the graph is undirected, and we return the graph. Now the main execution. Here we will build the graph dynamically based on the user input. Now we take the input starting node from the Prim's algorithm, and we get the MST and its total cost. Now we print the minimum spanning tree and the total cost. Now let's see the output. Here we have taken the number of edges, and all the edges are printed here. All the edges are taken from the user, and we should give the start node. Then it gives the minimum spanning tree along with the total cost.